All right, people, we want to talk expected value. There was something that came up in class the other day that in the chat boxes that I wanted to bring up to you because it was a really good point. So one of the exercises that we were working on was this game at our Rando virtual arcade, and there was this bag, and in the bag there was one $20 bill. There were two $10 bills. There were three $5 bills. And then there were four $1 bills. Here we have this is the quantity of the bills. We'll put Q for quantity. And then here, this column, this is our value. That's the value of our bills. And then we also have to consider the probability, we'll call it PR, of picking that particular bill out of this bag. So in this case, let's see, how many bills in total are there? Well, there's 1 plus 2 plus 3 plus 4, so there's 10 total. So the probability of picking the $20 bill was 1 out of 10. The probability of picking the one of the $10 bills is a 2 out of 10 because there are two of them. And there's three $5 bills out of 10, and then there are four $1 bills out of 10. And the way I was showing you how to calculate it the other day was to take the probability times the value of that event occurring. So if you pick the one $20 bill, it's $20, but the probability of getting that is a tenth. So we take the value times the probability. In this case, we get, so it's 20 times 1/10. So that ends up being 20 over 10, which is 2. And this 2 means over the course of many, 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 many times, this thing will contribute about $2 per turn. And then if we look at this row here, so it's $10 times this probability. Well, that's again, so it's 10 times 2/10, which is still 20 over 10, which then equates to 2. Okay, not too bad. So we just keep doing this. The value times the probability. So then we get 5 times 3/10, which is 15 over 10. Let's go ahead and we can reduce that down. That's a pretty straightforward improper fraction. It's just 1.5. And then lastly, 4/10. So it's 1 times 4/10, which is just 4/10, which if we go to decimal, which you don't have to, but I'll do it just for the sake of doing it. There we go, great. And then he said we sum these up. We take the sum of all these values. So then it's the sum of this. So it's 2 plus 2 plus 1.5. So that's 5.5. So it ends up being about $5.90. So that means over time, after we do this lots and lots and lots and lots of times, each draw on average we could expect to be about this much, or to be this much, $5.90. Each time you reach your hand and grab one of these bills, on average, this is what it will be. Of course, there's the 1, there's the 5, there's the 10, and the 20, so nothing is that number, but we're talking averages. So something that happened in class was someone found a shortcut or a way to kind of bypass this, and that was it by adding all the values. Let me show you what it was, the exact example. All right, so this is the example we did in class. or on the Zoom call, I should say, and it was this dice roll at rando where if you rolled a 1, you got 0 points, 2, you get 2 points, 3, 0, 4, 0, 5, 0, and 6, you get a point. And so what was the expected outcome? I showed you this method and we got 5, or 0.5, excuse me. That's our expected value. But then someone said, well, hey, Southam, why do we have to do all that? Because I can just do 2 plus 1, which is 3, and then divide that by 6, which gives us 3, 6, which is a half. So in other words, taking the point values and dividing by the probabilities. So add the 2. So that means you sum the point values. Oops. And then divide that by, I guess this would be the number of outcomes. And so this is the method I showed you, and then someone said, hey, Southam, but this, look at how quick that was. And yeah, actually that's one of the beautiful things about mathematics, is that there are multiple ways to get to the same answer. So that's super awesome. And I want to tie this method that that one of you students came up with, and tie it back to this. And why is this method, which is more complicated in terms of more steps and more writing, why would one choose this over this? Or why can't we just always do this? And I'm going to show you that right now. So let's take this example we just did, and let's try this. Let's see what happens if we sum these values and then divide them by 10, because that's how many, or yeah, sum these values and divide them by 10. So 20 plus 10 plus 5 plus 1 divided by, there's 10, because there's 10 possible outcomes. So let's see, this ends up being 36 tenths, which is 3.6, which is not, it's not the same thing. So, but that's the reason we're not getting the same thing, is because we're not accounting for how many tens we're getting. So we're not accounting for both tens here. We're not accounting for all 3 5s here. We're not accounting for all 4 1s here. And that's one of the reasons why I multiply the probability times the value, 4 times 1, because that's how we need to consider how many there are. So small little change to that. So that's not going to work. But let's do this, but account for how many of each bill we have. So we've got a 20, and then we have 2 10s, and then we have 3 5s, and then 4 1s. And then we account for all 10 outcomes. And this is I hope this is starting to click for us, because now this 10 means there are 10 things we can pull out of the bag. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then we get, if we've done this correctly, we should get 59 up here, because 59 divided by 10 is 5.9. So let's see, 20, 10, 40, 55, 56, 57, 58, 59. 59 over 10, which there is our 590. So the method works that we talked about earlier in this class, this method, but the only difference is you have to account for how many there are. And in this case, there is only 1, 2, and 1, 1. But it can change when you have multiple of those bills, so the 2 10s. And so that's why when we're talking expected value, we oftentimes talking about multiplying the value times the probability. And then the other thing to consider is I want to get you a better understanding of what this number means. And by the way, these are dollars. Why does $20 give us 2? Like what's up with that? So we're going to talk about that. I'm going to do an example. So after many rounds of this game, we're going to kind of flash ahead in the future. Let's say we've done 100 of them. A 100 games, and let's think about what we might expect, because by the law of large numbers, which basically says the more times we do an event occurs, we get closer and closer to the true probability. So if we did more games at, let's say, 100, we would still expect, based on our probabilities here, that we'd expect 1 out of 10 to give us $20. So that means we would get 10 20s out of this game after playing it 100 times. So that means we take, but how much is that worth? How much are those 10 $20 bills worth? Well, it's $20 times the 10 divided by 100, which gives us the $2, because this is the average. We're saying on average, this is giving us $2 per game. Let's go even further. Let's say, but again, we're talking huge amounts of numbers, huge amounts of games, because that's what expected value is. Let's say we did a larger number. Let's say we did 200,000 games. Wow, that's a lot of putting your hand into a bag and pulling out bills. So let's see, 200,000 games, and over time we'd expect to see 1/10 of those games give us a $20 bill. So 1/10 of this value is going to be, or this number of games is going to be 20,000. So we'd expect this many 20,000 20s being pulled out of this bag. So let's think about what that means on average. Well, that puts us at $400,000 of $20 bills that we've pulled out of the bag. And there's been 200,000 games. So that means on average, this has given us about $2. All right, so there you go. I just wanted to share this with you, go over some of the details of expected values, how they work, how we can calculate them, and then tie back to what we talked about in class. Because I always think, this is what I miss about seeing you all in person, is it's hard to do this on a computer. So, this is where, you've heard me before, I'm a Luddite. And pencil and paper, man, that's mathematics. That's some sense making. All right, I'll see you all soon. Bye.